Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're going to be looking at the limit as x goes to 2 of sine of x squared minus 4 over x minus 2. So there's a couple things going on in here. First of all, we have a trig function. Trig functions, we need to know some basics for calculus, but we don't need to know too much, which is nice. Second of all, we've got this fraction here, and things look a little bit nasty here because if we plugged in our value, x is equal to 2, which, or x going to 2, if we plugged in 2 for our x right away, we'd get 2 squared minus 4 over 2 minus 2, so we get 0 over 0, and this is going to be a big problem. Okay, so we've already done our first check. Remember when we're working with limits? Sine functions we can actually bring on the outside of our limit if we want to, since there's nothing else in there. So we can just pop that in. And at this point, there's a couple different things that we can do. Because we have a 0 over 0 here, you could, if you wanted to, use L'Hopital's rule. And that is going to be very slick and very quick. However, I want to show you a different way because this is going to be useful throughout your career as doing algebra and calculus. Whenever we have an x squared minus some number squared, doesn't matter whether it's 2 squared or 1 squared or 3 squared, that sucker is always going to break up into x plus a times x minus a, no matter what. And we can see that because if we distributed that back out, right, if you did x and then x and a, we get x squared minus ax plus ax minus a squared. The stuff in the middle would cancel, and we get x squared minus a squared again. So this is super useful, and it would be one thing that would be worth it putting in your back pocket if that you have an x squared minus a squared. You can break it down super easy without having to do too much work. So actually, that's exactly what we're going to do here. We're going to take the limit as x goes to 2. We're going to break our numerator up. 4 is the same as 2 squared, so we're going to write that as x plus 2, x minus 2, all over x minus 2. And now we notice that our x minus 2's will cancel. And we get the sign of the limit as x goes to 2 of x plus 2. And as x goes to 2, that goes to 4. So our solution to this problem is sine of 4. And we're just going to leave it at that. It's not exactly pretty, but in the sense that it's not going to be a whole number, I should say. It's pretty enough as it is. But we're used to seeing whole numbers. Sometimes that doesn't happen. And sine of 4 is a valid solution. All right. Thank you so much for listening.